Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on November 10th, 2025, about 3 days ago. It introduces LMT, a multilingual translation suite that tackles directional degeneration with strategic downsampling and strengthens transfer with parallel multilingual prompting, with the 4B model surpassing IA 10113B and NLLB 54B, including a 7.5 comet point advantage in X to Chinese. The paper is titled, Beyond English, Toward Inclusive and Scalable Multilingual Machine Translation with LLMs. And the implications for model training and inclusive translation are quite significant. Also, the authors shared a GitHub repo. You'll find ready-to-use LMT models in multiple sizes, a transformers-based usage snippet, and SRC code with inference scripts. The repo also includes their SFT dataset links and a new Chinese-Mongolian evaluation set under data. Everything needed to run and evaluate is there. You'll find LMT 60 checkpoints in 0.6 billion, 1.7 billion, 4 billion, and 8 billion CPT and SFT variants, plus clear transformers quick start examples for translation. Alright, Table 1 compares leading multilingual machine translation systems. The table shows training scale, language count, Chinese-centric support, and the base model for each system. LMT lists 90 billion continued pre-training tokens in 60 languages, which signals broad coverage with explicit Chinese-centric capability. Several alternatives use Llama 2 or Gemma 2 backbones, while LMT builds on QN3, so the setup emphasizes modern capacity and balanced coverage. So, Table 1 set the landscape. Figure 1 shows why coverage and balance matter. The top panel depicts a performance gap that widens as languages become rarer, because accuracy tracks how much pre-training data each language received. Bele here means a multilingual reading test that probes basic understanding across many tongues. The bottom panel contrasts bilingual data, showing English to X is plentiful, while Chinese to X is sparse, which limits supervised adaptation. Well, Figure 2 shows a two-stage pipeline that builds the corpus and then adapts the model. Continued pre-training means extending the base model on large mixed text so it learns broad translation patterns, while supervised fine-tuning teaches it with carefully formatted parallel sentences. The top row gathers bilingual and monolingual data with rule-based and model-based quality checks to keep only clean pairs. The bottom panel mixes languages and then adapts from the base model to LMT. Alright, Figure 4 shows that keeping only a small share of reverse direction data preserves translation quality, while heavy reuse degrades it. Strategic downsampling means retaining a limited portion of X to English or X to Chinese training pairs to avoid many-to-one shortcuts. The dashed curves indicate that using separate non-symmetric data keeps scores steady. Even 0.5% retention stops the collapse. Performance peaks near 5%, and full reuse at 100% drags X to English and X to Chinese down. So, while Figure 4 stressed stability, Table 2 shows who actually leads on quality. The table reports Comet 22, a learned score that predicts human translation quality across high, medium, and low resource groups. LMT 64 billion consistently tops or ties the field, despite smaller size. A standout is X to Chinese, where the 4 billion model beats NLLB 54 billion by about 7.5 points, which signals strong parameter efficiency. So, Figure 5 shows how each component lifts quality through an ablation study, which means adding pieces one at a time to measure their impact. Continued pre-training delivers the largest jump, about 8 points. Strategic downsampling specifically fixes reverse directions because it reduces many-to-one bias, adding roughly 11 points in X to Chinese. Parallel multilingual prompting adds a steady boost, around 1 point. Together, the 3 steps push the model into the high 80s on Comet, showing complementary effects. Alright, 2 takeaways stand out. Strategic downsampling prevents directional degeneration by curbing many-to-one shortcuts, and parallel multilingual prompting boosts transfer, especially into low-resource languages. The broader implication is clear. Strong, inclusive translation no longer requires massive models, which lowers costs and reduces English-centric bias. That is it for the AI Research Roundup. I am Alex. Thanks for listening.